Article 352.10 of the National Electrical Code requires that electrical metallic tubing, rigid metal conduit, or intermediate metal conduit shall be used for protecting wires in commercial buildings unless specifically permitted otherwise. Article 250.118(3) states that the conduit shall be metallic and shall be connected to the equipment grounding conductor, which is typically connected to the panelboard grounding terminal. The inspector is likely interpreting the code requirement for metallic conduit to mean that it must extend all the way to the panelboard. This interpretation is consistent with the intent of the code, which is to ensure a continuous path for fault currents to return to the source. The primary purpose of grounding is to provide a low resistance path for fault currents to flow back to the source. This helps to prevent electrical shocks and damage to equipment. In the case of underfloor polyvinyl chloride conduit, the metallic conduit provides this path by being connected to the panelboard grounding terminal. An additional grounding conductor installed with the branch circuits would not provide the same level of protection as a metallic conduit. This is because the grounding conductor is not as robust as a conduit and could become disconnected or damaged over time. Additionally, paralleling smaller conductors with the branch circuit conductors is not permitted by the National Electrical Code. Based on the National Electrical Code requirements and the inspector's interpretation, the conduit for the underfloor branch circuits in the exam rooms must be metallic and extend all the way to the panelboard. The metallic conduit provides a continuous path for fault currents and ensures the proper grounding of the electrical system. The requirement for metallic conduit in certain applications, especially in commercial buildings and healthcare facilities like the doctor's clinic mentioned, stems from several key considerations regarding safety and electrical system integrity. Let's delve deeper into the reasons behind this requirement. Firstly, the metallic conduit serves as a dedicated equipment grounding conductor. This is a crucial aspect of electrical safety. In the event of a fault, such as a short circuit where a live conductor comes into contact with a metallic enclosure or conduit, the metallic conduit provides a low impedance path for the fault current to flow back to the source, typically the panelboard. This low impedance path is essential for quickly tripping the circuit breaker or blowing the fuse protecting the circuit. A rapid response from the overcurrent protective device minimizes the duration of the fault, reducing the risk of electrical shock, fire, and equipment damage. Secondly, the continuous metallic pathway offers superior protection compared to relying solely on a separate equipment grounding conductor run within a non-metallic conduit like polyvinyl chloride. While a supplemental equipment grounding conductor is required in many installations, the metallic conduit provides an additional layer of redundancy and robustness. The conduit itself is less susceptible to physical damage, disconnection, or degradation over time compared to a wire conductor. Thirdly, the National Electrical Code emphasizes the importance of minimizing ground impedance, particularly in sensitive locations like patient care areas. Lower ground impedance facilitates faster fault clearing and reduces the potential for voltage rise on metallic surfaces during a fault. This voltage rise, even for a short duration, can pose a shock hazard. Metallic conduit, when properly installed and bonded, contributes to a lower overall ground impedance compared to non-metallic conduit systems. Fourthly, the inspector's insistence on extending the metallic conduit all the way to the panelboard reflects a common interpretation of the National Electrical Code and best practices in electrical installations. While it might seem sufficient to transition to metallic conduit at a junction box above the ceiling, maintaining the metallic pathway continuously back to the panelboard ensures the integrity of the grounding system throughout the entire circuit. This eliminates any potential weak links or points of high impedance in the grounding path. Fifthly, paralleling equipment grounding conductors smaller than 1/0 American wire gauge is generally prohibited by the National Electrical Code for good reason. Paralleling conductors can lead to unequal current sharing, especially if the conductors have slightly different lengths or impedances. This can result in one conductor carrying a disproportionately large share of the fault current, potentially overloading it and compromising its ability to effectively clear the fault. The metallic conduit inherently provides a parallel grounding path, but it's designed to handle the full fault current without the risks associated with paralleled wire conductors. Sixthly, the requirement for metallic conduit is often more stringent in healthcare facilities due to the heightened sensitivity of patients and the critical nature of medical equipment. Electrical equipment used in exam rooms and other patient care areas must be especially reliable and safe to prevent any disruption of medical procedures or harm to patients. The extra layer of protection afforded by a metallic conduit contributes to this higher level of safety and reliability. Seventhly, consider the potential for future modifications or additions to the electrical system. Maintaining a consistent metallic conduit pathway throughout the branch circuit simplifies future work and ensures that the grounding system remains intact even after changes are made. It avoids the need to re-evaluate the grounding system every time a circuit is modified or extended. Eighthly, the National Electrical Code aims to provide a standardized approach to electrical installations, promoting consistency and reducing the potential for errors. Requiring metallic conduit in specific applications helps to ensure that all electrical contractors and inspectors follow the same guidelines, minimizing the risk of misinterpretation or improper installation. Ninthly, remember that the inspector has the authority to interpret the National Electrical Code and enforce it based on their understanding of local conditions and best practices. While you may disagree with the inspector's interpretation, it's essential to engage in a constructive dialogue and seek clarification on their reasoning. In many cases, the inspector's interpretation is based on years of experience and a deep understanding of the potential hazards associated with electrical installations. Tenthly, it's always a good practice to consult with a qualified electrical engineer or other expert if you have any questions or concerns about the National Electrical Code requirements. They can provide you with a professional opinion and help you to ensure that your electrical installation complies with all applicable codes and standards. In summary, the requirement for metallic conduit in underfloor branch circuits, especially in healthcare facilities, is driven by a combination of factors including the need for a robust and reliable grounding system, the importance of minimizing ground impedance, and the desire to provide an extra layer of protection against electrical shock and equipment damage. While polyvinyl chloride conduit has its advantages in certain applications, metallic conduit offers superior performance in situations where safety and reliability are paramount. The National Electrical Code prioritizes safety by requiring metallic conduit as a dedicated and robust equipment grounding conductor, ensuring a low impedance path for fault currents to quickly trip over current protective devices, minimizing the risk of electrical hazards. Metallic conduit provides superior physical protection compared to relying solely on separate grounding conductors, reducing the likelihood of damage or disconnection. In sensitive locations like patient care areas, the National Electrical Code emphasizes minimizing ground impedance for faster fault clearing and reduced voltage rise on metallic surfaces, further enhancing safety. Maintaining a continuous metallic pathway to the panel board ensures grounding system integrity, eliminating potential weak links or high impedance points. Paralleling small grounding conductors is generally prohibited due to unequal current sharing risks, while metallic conduit provides a safe alternative. Healthcare facilities demand extra protection due to patient sensitivity and critical equipment, making metallic conduit essential for reliability and safety. Consistent metallic conduit simplifies future modifications and ensures grounding system integrity after changes. The National Electrical Code aims for standardization, reducing errors, and promoting consistent installations through the requirement of metallic conduit in specific applications. Inspectors interpret and enforce the National Electrical Code based on local conditions and best practices, ensuring compliance and safety. Consulting qualified experts ensures your installation meets all applicable codes and standards, promoting safe and reliable electrical systems.